This video is going to just be describing series circuits and parallel circuits and just figuring out what the heck's going on. So for multiple bulb circuits, we can talk about a series circuit, which is one where we have one loop only and the bulbs go one right after the other. So in series with each other. It's a series of things, one right after the other. The other option for multiple bulb circuits is if we have each one with its own path, its own loop, and we call that parallel. And they behave differently, they do. And so if we were to look at the brightness of bulbs in series compared to our standard circuit, our standard one battery, one bulb. So standard. What we see is that this bulb and this bulb are dim and equally dim. This bulb is standard brightness. This bulb is standard brightness. So yeah, definitely something weird going on here. Let's take it one step further. What would we have if we add a third bulb, either in series or in parallel? So 3, 1, 2, 3 in a row, or 3, okay, 1, 2, 3. All right, so make a prediction. What do you think we would see with these 3 bulbs, 3 series bulbs, or 3 parallel bulbs? Well, it turns out that what we get is these are even dimmer, so dimmer than before, and still equally dim. So they are equal to each other and even less bright than those. Whereas here, standard brightness, standard brightness, standard brightness. So what we have going on here with the series circuit, and remember what bulbs do, bulbs act as resistances to the flow of charge in a circuit. So if I just have a single bulb, I've got just, okay, one kind of barrier, block, hurdle. Now I'm adding 2 hurdles. The resistance here gets bigger, resistance here even bigger. So by adding bulbs in series, I actually increase the resistance. So in series, resistance goes up with each bulb. In parallel, they're staying standard brightness. Doesn't matter how many in a perfect world. So we could keep adding and they all are standard. But if you think about it, they all have their own path to the battery. So this bulb says, I've got a path to the battery, I'm all happy. This bulb, I've got a path to the battery, I'm all happy. They don't interact with one another. They just are like, I'm in my own loop and la-di-da, I'm standard brightness. So same thing here. So in parallel, each path, each loop is independent. And here's the really weird thing. What we find out is that in parallel, the total resistance, I should put total here, the total resistance in parallel actually goes down. So a battery here, the battery here says, okay, there's a certain amount of resistance, more resistance, even more resistance. And so the amount of charge it's being able to kick around that circuit, well, here's a bit of resistance, so it's like, okay, I got some flow. Harder, I'm going to have less flow because it's twice as hard. It's going to be dimmer because there's less flow. 3 times the resistance, even dimmer. I have trouble pushing, so there's not much flow of charge going on. With parallel, this is really cool. So if there's just one bulb, the battery says, okay, I have to light one bulb. I add another one. The battery says, okay, I've got to light this one. Oh, and I've got to light that one. I have to put out more juice. I have to put out enough flow to cover this one and to cover that one. Here, I've got to put out enough flow of charge. I've got to have enough flow of charge to light this one, and this one, all standard. So here, the amount of charge that flows goes up, and we know that if the flow of charge goes up, resistance goes down. Now this one is counterintuitive. I'm adding bulbs, which are resistances, but somehow the total resistance of the circuit goes down. What the heck is going on there? So here's an analogy for you. Imagine it's the week before Christmas and you are shopping at your favorite large box store and you would like to get out, right? So what is the resistance to the flow of people out of the store? What keeps you from going out of the store? What do you have to pass through? Checkout lane. Okay, so a checkout lane is a resistor to the flow of people. People are the charges. They're trying to get out, but you have to stop, slow down because there's a checkout lane. If we start with just one checkout lane, then there's a certain amount of flow. If you have to go through 2 checkout lanes in a row, what would that do to the flow of people out of the store? So here you have to do 1 checkout and then this person's going to do the same thing. They're going to check out all your stuff again, just to be sure. Well, you can imagine that the flow of people out of the store is going to go way down. This is what happens at the airport, because if you've flown recently, okay, you have to show your boarding pass and your ID to the first one, and then you've got to do the baggage check, x-ray, whatever. And so there's 2 barriers to the flow of people, which is why it takes forever to get through from the main lobby of the airport into the gate area. What about parallel? So let's go back to the checkout lane. All right, we have 1 checkout lane open, and we have a certain amount of flow of people out of the store. We open a second checkout lane where the people can choose, oh, some of us will go here, some of us will go here. The flow of people out of the store goes up. It's going to go up even more if we add yet another checkout lane. And so the flow of people keeps going up every time we add a checkout lane, even though the checkout lanes are resistors to the flow of people. So that's just a conceptual way to think about series and parallel. Series, one right after the other, and things get dimmer. Parallel, each has its own loop. Each loop is independent, and everything stays standard because they all have their own path to the battery. So there you go. Good job for watching.